Question 13. Electrons with a certain kinetic energy pass through a powdered crystalline sample are incident on a fluorescent screen. The diagram shows a sketch of the diffraction pattern produced. You see some rings here. A change is made and this second pattern is produced. Okay, so these are bigger wavelength compared to those. Wavelength is the distance between the wavefront, and this is a bigger wavelength. Which change could produce the second pattern? A. Decreasing the kinetic energy of the electrons. Looking at the kinetic energy, we could say that the kinetic energy, which is P squared over 2m, is mv squared over 2m. And that's the kinetic energy. For A, if you decrease the kinetic energy of the electron, here's the kinetic energy. So lambda is h over momentum. That's de Broglie wave. If energy goes down, the wavelength will go up and the velocity goes down. For B, where we have replacing the electron with protons with the same kinetic energy, so we got the kinetic energy now, and that implies that we can make P the subject momentum. For lambda will be equal to h over root 2me. When the wavelength goes down, the mass will go up because we're talking about the replacing the electron with protons, so the mass will be higher because proton is 2000 times higher than the electron. For C, using a crystalline sample with a wider spacing between its atoms, so we're looking at diffraction here and making D the subject. When D goes up, the angle goes down. For D, we moving the screen closer to the crystalline sample. Again, we're looking at the width fringe. D is the distance between the screen and the spacing. So if D goes down, we expect the width is directly proportional to go down. Rings will be closer together. A is the answer.